Welcome back to the next session of units and measurement. Friends, till now we studied the measurement of large length, measurement of small length, measurement of mass and measurement of time. Henceforth, we are stepping into the one more important concept, that is measurement of errors. So, before understanding the word error, we should understand some more words which are related to the word called error. That is accuracy, precision and all. Once if we study these concepts, then handling any experimental apparatus in the laboratory, either in physics or in chemistry or in any other laboratory, will be very much helpful. So now, friends, let us understand the important concept one by one. The heading is accuracy, precision of instrument and errors in the measurement. First one is we have to understand what is the error. Error means even you would have experienced in your mathematics class when you are drawing the geometry, when you are learning the geometry. Suppose if a mathematics teacher says to you, draw a circle of 5 centimeter radius, then what you will do? You will take a compass, you will mount the pencil, then you will measure 5 centimeter stretch to 5 centimeter, then you will make a mark at the center of the circle, then you will rotate, then you will make or else you will draw a circle. And from the center you will join the circumference, saying that O to A, that is OA radius is 5 centimeter. Then if you take the scale and again if you measure the distance between the center of the circle and the circumference with the help of scale, some of you draw either exactly 5, good, but some of you measure 5.1, some of you measure 4.8, 4.9, something like that, because the screw of the compass may be very tightened. At that time, stretching to that extent is not possible. That means it is not well calibrated. Or if it is exceeding 5, that is 5.1, or not exactly coinciding on 5 centimeter line, then what you say? It is more or less. That more or less is there, no? That uncertainty. That uncertainty itself is termed as the error. The uncertainty in the measurement of physical quantity is, say, error. Suppose if I want to measure the weight of my body, if I measure, then suddenly it will show 65 kg. Do you think that exactly 65 kg? Not in terms of grams? Yes. Say 65 kg, 600 grams. Do you think that 600 grams exactly? No. Again, still further number are there, 625 grams say. Then 65 kg, 625 grams. Exactly 20 grams, not milligrams. Milligrams are there. So, but we are neglecting the accurate values, considering only the round figure. At that time, the uncertainty comes into picture. This uncertainty itself is termed as what? The error. Or it's one more definition I wrote here. The difference between measured value and the true value. What is meant by measured value and true value? Somewhere I measured, or somewhere I know that the standard value of this is, say, gravitational force. The acceleration due to gravity of Earth is 9.8 meter per second square. That we know. Suppose if I calculate the acceleration due to gravity in our laboratory with the help of certain devices, say simple pendulum. Suppose if I measure the gravitation force in the laboratory, you may get 9.6 or 9.7, or you may get 9.9 or 10. Look at this. The true value is 9.8, but the measured values are 9.7. Then take the difference, 0.1. That 0.1 meter per second square is there. That uncertainty itself is called as what? Error. Second thing is, let's go for the accuracy. Now only I say accuracy means what? So what is the true value? True value is 9.8 meter per second square. That was simple. I am taking an example. Acceleration due to gravity is 9.8 meter per second square. Suppose if I measure the value inside the laboratory. So now, so let us say two friends. Two friends are performing two experiments in two different laboratories, and their motto is to calculate the gravitation in that particular zone. Say one is calculating 9.7, another one calculating the 9.6. Now you only decide. True value is how much? 9.8. What is the value now? Measured value? The measured value in one laboratory is 9.7. In another lab is 9.6. Now you compare the accuracy. Which one is very close to the true value? My always 9.7. So now it is the closeness between the measured value and the true value of physical quantity, right? So 9.7 is very close to what? The 9.8 meter per second square. That is, lab 1 is very accuracy. That means he performed experiment very perfectly. That is why he got the value. That is called as accuracy. Science is all about accuracy, right? It's all about measurement. Then let's go for the precision. So precision is what? It is a limit to which the measurement of physical quantity is done. So what exactly the meaning of this? Let us say I'll give one apparatus. Let us say I'll give a scale, meter scale. I'll give measure the length of a given wire. Say now you are measuring the value, say 3.985. This is what meter. So this is what the measured value. Now I'll give the same value with another list count. That list count, everything will learn in the laboratory with handling the apparatus. That will come to the later part. So I will give another scale, not of the same kind, another kind I will give. So another fellow is measuring. So now we got the value, say 3.8, exactly 3.8 centimeter. No next figures, exactly 3.8. The next thing is another fellow will come. He measures the value, then say 3.757 or 756 meters. Look at this. Here, this is what? The true value. These two are what? Measured value. Look at the precision now. This is very accurate, almost accurate value, but have what? Less precision. Or it has less precision. Suppose, this is what? More accurate, but less precision. If you got this one, less accurate, but more precise or more precision is there. Look at this value. Though it is differentiating, look at this. This is a value, true value. One is measured, he got value 3.8, and one measured 3.756. Look at the value, 3.75 is all 0 here because he can't measure more than 3.8 by the universe scale itself. You can measure 3.8 centimeter in your scale, but you can't measure 3.85. Possible? No. So this is not possible. So he restricted himself 3.8, but he measured with another apparatus 3.756 meters. He entered two more values. So hence it is less accurate but more precise. So in this way, so we can study the value of precision. The limit. At what limit we are measuring the true value to the measured value. So now, after studying all these things, let's go to the next type, that is types of error. Suppose if you want to study the types, how many types of errors are there? So basically, how many types are there? There are two types of errors are there. Two types of errors are there. Namely, if I name them, so A and B. A is systematic error. B is random error. Random error. So what is meant by systematic error? What is meant by random error? Suppose if I go with A, that is systematic error. Systematic error. What is meant by systematic error? What is meant by random error? The name itself is saying that systematic. That means something systematic is not puzzled, not shuffled reading. It is shuffled error. It is systematic. That means what? It always tends to move in one direction. So the systematic error, it always tends to be in one direction. It is tends to be in one direction, either positive or negative. What is the meaning of this? That means what? In the systematic error, once if you make the error by measuring any value or with any instrument, the every value, if it is changing positively, throughout the experiment it will go in only one direction, positive, increasing, or else decreasing. That means, suppose, say in one length you want to measure, it is 5.7. Actually it is 5.5. What happened here? The length is increased by 0.2 centimeters. 0.2 centimeter. Suppose if you measure one more next value, one more length, say now you want to measure 6.5. So when you are measuring 6.5, it will go 6.7. If you want to measure 7.7, 7.5, it will go 7.7. So that means what? The error is occurring in only a particular direction, positive error. Suppose if I go with the negative error, always in the decreasing order. So positive direction or else negative direction. So that is why it is called as tend to be in one direction. Then the systematic error again broadly classified into three types. So now again systematic classified into classification of classification. So now if you classify this systematic error, again there are three types of errors are there. So one is instrumental error, second one is personal error, then another one is systematic error, personal error, then one more thing, sorry. External error. So there are three types of error. Procedural errors are also there. So let's write one by one. Number one, instrumental error. Number two, personal error. Number three, procedural error. So again this is classified into many ways, but this much is sufficient. Let's see one by one. What is meant by instrumental error? Now, for this I can give a very funny example which you have enjoyed in your childhood or especially in mathematics class. When geometry class, in the geometry class, let us say start one by one. In the geometry class, sir says, in the middle of the page, you draw exactly 3.5 centimeter, exactly at the center. You will take your scale, you will take your pencil, then you will draw. And one of your friend is struggling to draw 3.5 centimeter. Do you know the reason why? He also has a scale. You also have a scale. But the problem is the lines which are there on the scale, that is measuring value 3.1 centimeter, 3.2 centimeter, 3.3 centimeter, those lines are invisible, not clear, right? Are very blurred. You can't see. Then what happens? Obviously, the instrument is not supporting. That instrument is a simple instrument, scale, but it is not supporting him to measure the exact value of 3.5 centimeter. So he suffers. He will make mistake. Then what he will do? In a random way, he will draw the diagram by saying that, thinking that I am drawing 3.5. He may draw 3.6 or he may draw 3.5. So just simply it is what an assumption happens. So one thing, similarly, while measuring any length or depth or width, thickness, whatever you are measuring in the laboratory by using the vernier calipers and the screw gauge in the laboratory, you may make such errors with the instrument. These errors are associated with the instrument, not with you, right? So instruments, that is called as calibration. Calibration means what? Preparing the instrument to read. right? So we will keep throughout the year, we'll keep in the laboratory. So once the lab opens, then we'll call you inside the laboratory, then we'll give the lab instrument to you. Suddenly you start handling, will it work? Maybe, may not be. But what I have to do? First I have to make it a proper way. It's a systematic method to read how it should read, wherever the line should be. That accuracy will be made. That is called as calibration. That preparation we will do in the laboratory before you enter the lab. That is called as what? Instrumental error. That means these errors are associated with the instrument, not with you. Let's come to the personal error. In the personal error, let's see what is meant by personal error. Suppose if I say do this experiment, right? Say you have some emergency to go somewhere. What you will do? You will listen very, you are not listening properly. First thing. Second thing, you will do very haphazardly experiment. So that means what? You are not so much aware of the explanation. Lack of explanation, not interested in the lab, or you have some emergency work. At that time, you will not measure the things in the proper way or in the proper direction. Hence, this personal error come into picture. It is only because of you people, right? The next one is procedural error. Procedural error means what? There is a systematic way to do the experiment. If you take any experiment, there is a systematic way to perform the experiment. At that time, if you people are not aware of the entire procedure, beginning point till the result point, if you don't know the procedures, even if you skip one simple procedure, so what happens? Error come into picture. You will not arrive at the true value, or you will not arrive at the result. So at that time, lack of experimental knowledge, so that leads to the procedural error. Then if I go to the random error, that is B. So if I want to explain about the random error, so these are what they occur in a irregular way. So these are occurring irregularly. These are occurring irregularly. Irregularly means what? Suppose if I want to measure one experiment exactly at 27 degrees Celsius, or it's at 300 Kelvin, but now if I perform, it won't work because it's too cold. It won't work. Suppose if I go perform in the spring season at the early morning, at 8 o'clock, say 7 o'clock or 8 o'clock, temperature will be very less than 27 degrees Celsius, it won't work. And suppose if I want to perform in the summer season, it is exceeding more than 27 degrees Celsius, it won't work. So in this way, some atmospheric condition as temperature is concerned. Suppose if I go with the pressure, suppose if I go with the force, if I go with any other such things, at that time a randomness comes into picture in a very irregular way. So these type of random errors are called as what? Irregular errors. Thank you. Now, one more important topic, and along with this, we have studied the errors in a broad way. Let me explain one more important concept, that is least count error. Before understanding the least count error, let us understand the meaning of least count. So in short, it is called as LC. So now take a scale. If you take scale, so now we will take a 15 centimeter scale. In that 15 centimeter scale, what is the minimum value you can measure? 1 centimeter, because 1 centimeter is the minimum centimeter. Then even if I go a little bit smaller than that value, then we will come to what side? Millimeters. 0.9 centimeter. That 0.9 centimeter is termed as water. 9 millimeter, 8 millimeter, 7 millimeter, so on. We come to what? 0. Next value is 1 millimeter. Then, if you take in a broader way, 15 centimeter, smaller way, 1 centimeter, even smaller way, 1 millimeter. Now, in the next, can you go even lesser than that? 1 millimeter less than in your scale, using your scale? Not possible. That means what? That is the LC or the least count of that scale. Take a watch. So in your watch or in any clock, if you take a clock, in the clock, what is the minimum value? Say hour, less than hour, minute, less than minute, second. So 60 minutes is equal to 1 hour. 60 seconds is equal to 1 minute. Then 1 minute equal to, or then 1 second is equal to, less than 1 second is possible to measure with using your clock. Stop clock possible, but what about the wall clock or wristwatch? Not possible. So 1 second is the least count of the watch. It is the minimum measurable value in an instrument. Minimum value measurable in an instrument. It is the minimum value that can be measured in using any apparatus or any electronic or any device. It is called as LC. Even with this LC also, there are some error factors that is called as least count error. Least count error. Some of you have the devices called as say 1 point. So between 0 to 1 centimeter, if you see 1 centimeter, 2 centimeter, there will be 10 lines. But if you see between 0 to 1 centimeter, there will be 20 lines. That means what? Even the LC of that particular scale is 0.5 mm. That means even 1 millimeter second split into 2 exact halves. So that becomes what? 0.5 millimeter is the LC of that particular scale. But you can't measure throughout. It's between 0 to 1 centimeter. It is possible. So in that time, error will occur due to that LC also. That is called as least count error. With this, I am completing the topic accuracy, precision of instrument and errors in measurement. In the next class, we study one more topic. Thank you.